Welcome back to Refreshing Careers. Today we are going to do the part 4 of linear programming, and again we are going to solve a problem today. Today's question is this. To increase the production of crops, a scientist suggested that a farmer should spread at least 4,000 kg of urea fertilizer and 7,000 kg of nitrogen fertilizer. These fertilizers can be obtained by using two mixtures, namely M and N. Both these mixtures are available in bags of 100 kg each. The price is ₹50 and ₹30 respectively. Mixture M contains urea and nitrogen equivalent to 60 kg and 40 kg respectively, while mixture N contains these ingredients equivalent to 50 kg each. Formulate an LPP for the problem. Okay, so let's understand the question first. What they are saying? They are saying that there is a farmer. This farmer was suggested by a scientist that he should be using at least, please note the word at least, okay, should be using at least 4,000 kg, should be using at least 4,000 kg of urea fertilizer and 7,000 kg of nitrogen fertilizer, okay, so that he could increase the production of crops. So this scientist has told the farmer that he has to use at least 4,000 kg. That means minimum 4,000 kgs of urea. Minimum 4,000 kgs. It should be either equal to or something more than 4,000. It cannot be less than 4,000. That is what they mean. Similarly, for 7,000 also, the scientist says that the nitrogen fertilizer has to be used, but it should be equal to 7,000 or more than 7,000. Like minimum that you can use is 7,000. So they are saying minimum 7,000 kg and minimum 4,000 kg, or it's at least. At least the word used here is nothing but minimum 4,000 kg, minimum 7,000 kg has to be used. Okay, so the scientist has given this advice. The farmer wants to implement it now. These fertilizers can be obtained by using two mixtures, namely M and N. So now the farmer finds out that there is mixture M and there is mixture N. Mixture M contains 60 kg of urea and 40 kg of nitrogen. Mixture M contains 60 kg of urea and 40 kg of nitrogen. Mixture N contains 50 kg of urea and 50 kg of nitrogen. So these are the two mixtures available in the market, and he is going to buy these two mixtures. He wants to buy these two mixtures. The ratio of urea and nitrogen in this mixture is 60:40, and the ratio of that is 1:1, that is 50:50. Okay, this is what the question has been told till here. The next point which is mentioned in the question is that these mixtures are available in bags of 100 kg each. So when the farmer goes to market to buy it, he has to buy bags. He can't get 1 kg, 2 kg. He is buying means he has to buy a bag, and that bag is equal to 100 kg. So in this question, we would have to find out how many bags of M we need to purchase and how many bags of N we need to purchase. Okay, and each bag will be 100 kg. We need to find out how many bags of M is required and how many bags of N is required. The price is ₹50 and ₹30 respectively. The price of one bag of M is ₹50. The price of one bag of N is ₹30. That is what the question says. Now we have to first figure out what is the objective function. So we have to find out what is the objective of this question. What is the question asking us to do? Whether we should minimize or whether we should maximize. In this question, the farmer wants to purchase something. When you're purchasing something, it's about reducing the cost, right? We are going to purchase something, so our aim would be, our objective would be to buy it at the least cost possible. Okay, and since this is a case of purchasing, by reading the question, you can make out that here we want to, our objective is to reduce the cost as much as possible. We have to buy such a combination of M and N that we are able to do what the scientist has told, and also the farmer is spending as less as possible. You have to make sure the farmer is spending as less as possible, and also what the scientist has told is done. Okay. So now let's go to the objective. So objective is to minimize. This is the objective function. The objective is to minimize cost. In this question, we are minimizing cost. You have to buy it at the least cost. Okay, least cost possible. You have to buy bags of M and the bags of N at the least cost possible. That is our objective. That's why here we get to know that the objective is this. Let us assume that the total cost is X. Okay, here since we are reducing the cost, okay, we want the total cost to be the least. Okay, so we have to assume total cost to be something. We can assume this as anything. I have taken this as Z. Okay, so the total cost is taken as Z. Now total cost is what? Total cost will be the cost of purchasing M bags and the cost of purchasing N bags. The cost of purchasing M bags and the cost of purchasing N bags. I'll just modify this a bit. The cost of total M bags, and this is cost of total N bags. Cost of total N bags. Okay. So it's more clear now. So the total cost will be cost of M bags, the total M bags, and the cost of total N bags. And we don't know how much will be the cost, because we don't know what is the quantity we are going to buy. Quantity of how many M bags we are going to buy, we don't know still. How many N bags we are going to buy, we don't know still. That is what we need to figure out in this question, and whatever we need to figure out in the question becomes our decision variables. These are the decision variables, because the number of bags we buy would reduce the cost. That is what that is what is the deciding factor. That is what would minimize your cost, because as I told you, we cannot change the price. The price of input and output will always be constant, since that is an assumption in the beginning itself. We have assumed that prices cannot be changed. So you can reduce the cost, or you can increase profit only by playing around with the quantities. Thus quantities becomes a decision variable. Okay, now cost of M bags. Cost of M bags will be total bags of M. Total bags or number of bags of M into price per bag of M, plus total bags of M into price per bag of N. Total bags of N into price per bag of N. Okay, price per bag of M, that is given in the question. That is this. Price per bag of M is rupees 50. So we put it here. Price per bag of M replaced by 50. Price per bag of N is given here, rupees 30. So we put it here. Price per bag of N is rupees 30. Now we don't know what is the total quantity of M that is purchased. We don't know number of bags purchased. We don't know number of N bags purchased. So let us assume that total bags of M be X1. Let total bags of N be X2. So your total cost will be equal to total bags of M into price per bag, that is 50, plus total bags of N, that is the X2, which is what we have assumed, into price per bag of N, which is 30, as given in the question. And that's how we get the objective function. And the objective function is this linear equation, that is Z is equal to X1 into 50 plus X2 into 30. X1, X2, they are a decision variable, and it has to be such that we get the least cost. Okay, a cost should be least. X1, X2 should be such a combination, should be such a number that would give us the least cost. Okay, that is our intention, that is our objective, to minimize cost. Next is constraint. As we saw previously, same thing, it repeats, constraint. Now what are the constraints here? This is a constraint. That is, it can't be less than 4,000, it has to be 4,000 or above 4,000. So this is the constraint. It can't be less than 7,000, it has to be 7,000 or more than 7,000. This is a constraint. So in case of urea it is 4000, in case of nitrogen it is 7000. So let me write down. Urea 4000, nitrogen 7000. Urea, I'll just write it as U. Urea 4000. Nitrogen is 7000. Urea 4000, nitrogen 7000. Okay, and then what are they saying? Then they're saying that mixture M contains urea and nitrogen equivalent to 60 kg and 40 kg. Okay, so urea in M is 60 kg, urea in N is 50 kg. Okay, urea in N is 60 kg. So first we are going to write the constraint for urea. Urea constraint. Okay, first is urea constraint. So here we know that in N it is 50 kg urea will be there, and in M 60 kg urea will be there. Okay, that's what is given in the question. So now I have to put it down as an equation. So 60x1 plus 50x2, and urea should be minimum 4000. Should be minimum 4000. That is, it can be equal to 4000 or it can be more than 4000. So you can use a greater than sign. That's why I've used a greater than sign and equal to sign. And the second constraint is related to nitrogen. So the nitrogen constraint. Nitrogen constraint. Okay, what's the nitrogen constraint? Its question says that in M there is 40 kg nitrogen and in N there is 50 kg nitrogen. Okay, 40 kg and 50 kg. So it is 40x1. Sorry, it's not I, it's x1. 40x1 plus 50x2 greater than or equal to 7000. Okay, I'll again repeat how this came. The first constraint is related to urea. They have said that minimum it has to be 4000. That means this entire thing, okay, this 60x1 plus 50x2 is the total urea that is going to be purchased by the farmer, and this total urea that is going to be purchased by the farmer can be 4000, can be equal to 4000 kgs, or it has to be greater than 4000, or it has to be greater than 4000. That is what it means. Here the farmer is going to purchase total of this much of nitrogen, that is 40x1 plus 50x2 is the total nitrogen that the farmer is going to purchase. Still we don't know what is that amount, but we know that this is the total that he is going to purchase, and this whatever he is purchasing has to be equal to 7000, or it can be greater, or whatever this is, this figure can be greater than 7000, because they have said that it has to be at least 4000 and at least 7000. That's why this has come. Okay, that's why I use the greater than equal to symbol, and that's why I use greater than equal to symbol. And the next thing is how this equation has been formed. We know that in mixture M it is 60. Okay, 60 kg urea is there, and in mixture N 50 kg urea is there. So 60 into number of bags of M plus 50 kg into number of bags of N. That will give you the total urea. So this we are just finding out in totally how much urea is there is what we are finding out. Similarly for this also, nitrogen and trying to figure out what the total nitrogen. 40 is the nitrogen in M, in mixture M. 40 is the nitrogen in mixture M, 50 is the nitrogen in mixture N. Okay, that we are multiplying with x1 and x2. x1 is the total bags of M and total bags of N. So when you multiply that, you will get the total nitrogen. So 40x1 is the total nitrogen from M, and 50x2 is the total nitrogen from N. That is 50 kg is the nitrogen that is there in the mixture N into number of bags, into x2 is the number of bags of M. That will give you total nitrogen that mixture N is going to give you. The purchase of the bags, x2 bags of nitrogen, x2 bags of mixture N is going to give you. Okay, that's how this is formed. This is urea constraint, this is your nitrogen constraint. And the next is non-negativity condition. Non-negativity condition is same like you saw previously. Your x1, your x2 can be positive, can be negative, can be positive, can be negative, can be positive, can be 0, but cannot be negative. Okay, can be positive, 0, cannot be negative. It can be positive, yes. It can be equal to 0, yes. It cannot be negative. It cannot be negative. That is what this is, non-negativity constraint. And what is your x1, x2? It's the total number of bags of M, total number of bags of N. See, your number of bags, you can buy 0 bags, you can buy 1 bag, 2 bag, or any positive number of bags. But you cannot buy -2 bags, -8 bags. That's not possible. Okay, that's what this is. Non-negativity condition is being put. Now we have to summarize the entire thing, whatever we have just equated. The first is the objective function. That is Z is equal to x1 into 50. Z is equal to x1 into 50 plus x2 into 30. So Z is equal to x1 into 50 and x2 into 30. And this is subject to, and this is subject to the constraints. What are the constraints? This is the first constraint, urea constraint. 60x1 plus 50x2, 60x1 plus 50x2 greater than equal to 4000. Next is 40x1 plus 50x2 greater than equal to 7000, greater than equal to 7000. And your non-negativity condition, that is x1 greater than equal to 0, x2 greater than equal to 0. Please do like and subscribe the video. Thank you so much.